Hey guys, welcome to part 1 out of 3 of my new series. Today we're going to be talking about experimental determination of the empirical formula. We've talked about the empirical formula before in previous videos, but today we're going to talk about how to find it. Let's get into today's video. First, let's go over last week's problem. The molar mass of copper is 63.55 grams, and the molar mass of chalcopyrite is 183.5 grams. I found that by adding the masses of Cu, Fe, and 2S. I divided the molar mass of copper by the molar mass of the molecule and multiplied it by 100 to get 34.63%. That means 34.63% of the mass of chalcopyrite comes from copper. We have 3.71 times 10 to the third kilograms of chalcopyrite, and that multiplied by 34.63%, or 0.3463, is 1.28 times 10 to the third kilograms. That's the mass of copper in that sample of chalcopyrite. If you recall from past videos, the empirical formula is the simplest form of a molecule, while molecular is the actual form. For example, C2H4 is the molecular formula, but we can simplify it to CH2, although this wouldn't be the proper way to identify the molecule. Now let's talk about how to find the empirical formula. To find it, you need the percent composition of the compound. We learned to find this in my previous series, Counting Particles, so check videos 15 through 18 before moving on if you haven't already. The steps required are 1. Know the masses of the elements in the compound in grams. 2. Convert each element to moles. And 3. Simplify as necessary to get the empirical formula. Let's do an example with ethanol. When ethanol is burned, it creates CO2 and H2O. So we know that it contains C, carbon, H, hydrogen, and O, oxygen. We're assuming all the oxygen in the products isn't accounted for by the O2 that's added to the ethanol. Let's say that this combustion process used 11.5 grams of ethanol and produced 22 grams of CO2 and 13.5 grams of H2O. To find the mass of carbon, we multiply the mass of CO2 that we have by 1 mole of CO2 over its mass, which is 44.01 grams. Then, we multiply it by 1 mole of carbon over 1 mole of CO2, since there's only 1 carbon atom in CO2. This gives us the moles of carbon. Finally, we multiply by its molar mass, which is 12.01 grams of carbon for every mole. This equals about 6 grams. Then we do the same with hydrogen and H2O. The H2O is 13.5 grams. We multiply that by 1 mole of H2O over its mass, 18.02 grams. Then we multiply it by 2 moles of hydrogen for every mole of H2O, since it's H2, not just H. And finally, we multiply it by hydrogen's molar mass, which is 1.008 grams per 1 mole. This is approximately 1.51 grams of hydrogen. Now we subtract these masses from the masses of ethanol that we have. That's 11.5 grams minus 6 grams of carbon minus 1.51 grams of hydrogen. This leaves us with about 4 grams, which is the mass of the oxygen. Now we have to convert all the elements back into moles by dividing it by its mass per mole. 6 grams of carbon times 1 mole per 12.01 grams is 0.5 moles of carbon. 1.51 grams hydrogen times 1 mole hydrogen per 1.008 grams is about 1.5 moles hydrogen. And finally, 4 grams of oxygen times 1 mole per 16 grams of oxygen is 0.25 moles oxygen. If we write this compound, we get that ethanol is C0.5, H1.5, O 0.25. This is not how we want to write it, since we can't have parts of an atom for each element. So let's divide the whole thing by 0.25, the smallest subscript of the 3. This gives us C2H6O, which is the structure for ethanol. If you understood how to do that problem, you probably now understand why it's called the empirical formula. It means based only on observation and measurement, and that's what we did. We used the measurements to find the simplest form of ethanol. Let's review. Empirical formulas are the basic formulas for any compound that can be found using the molecular masses and the percent composition. I know this can be hard to understand because you have to use everything you've learned all the way from video 1. So make sure you're keeping up with the videos if you want to understand. As long as you know the information that you have, the information that you need to know, and the conversions to find that information, you're all good with empirical formulas. Please like, share, comment, and subscribe for more videos every week.